Hello class, here we are at Case Study 2A Notes Part 5, titled T Practice Continued, okay? This is where, if you'll look over here to the right side of the board, screen, weird, we're going to look at two-tailed hypothesis. So we haven't really talked about two-tailed hypothesis since the beginning of the semester, but now that we've had a lot of time to practice left-tailed and right-tailed hypotheses, we've had the past week to be going over our t-distribution and making sure we feel comfortable using the table. And so now we're going to incorporate the idea of two-tailed hypothesis testing. Okay, so for these problems, assuming a normal population for these numbers 7 through 9, complete the following steps of hypothesis test. Calculate the test statistics, state the null distribution, calculate the p-value, and state the decision, again using alpha of 0.05. Okay, so just kind of how we left off last time, I was giving you the hypothesis and I was giving you X bar and S and N, and we're actually going to have to plug into our test statistic formula. Now, before you go on to doing that, notice the two-tailed, what that means is this do not equal to sign in our HA. And HO, like always, has our equality sign. Okay, so you're going to plug in 36.1 for X bar. You're going to plug in 34.8 for mu. You're going to plug in 1.1 for S, and you're going to plug in 22 for N. Okay, and so again, anytime we're doing a calculation, that's a great time to pause, make sure that you're doing the calculation in your calculator correctly, and that you get the number 5.54. I don't remember if I said it in the last notes, but whenever you are plugging this quantity into your calculator, you do want to use brackets or parentheses around the top and the bottom in order to get this number 5.54 accurately. All right, so that's our test statistic. So we did our test statistic, check, state the null distribution. Okay, so since this is a t-test statistic, the null distribution is going to be students T, where we're concerned with degrees of freedom. And so degrees of freedom, remember that calculation is N minus 1. So how we write our distribution is just like that. The T test statistic, so this is, let me get some colors in here. The T is our test statistic T, okay? And then the T21, okay, that's going to be the physical picture that we would draw and the act of going to the chart. This is T21, okay, the student T distribution. Okay, so when it comes to writing p-value, okay, we tend to always look at the sign in our HA, and we use that. Now we have a do not equal to sign, and so it's going to kind of affect the way we do our p-value. Okay, so let's take our t-test statistic that we have of 5.54, and I'm going to mark it on my number line. And this is 5.54. Okay, now the thing about being two-tailed is I don't want to just consider the left tail or the right tail. I physically want two tails going on. So we're also going to come back here and do negative 5.54. Okay, and so I'm going to shade the area that's to the left of negative 5.54 and to the right of positive 5.54. So what I have shaded in pink is going to become our p-value. All right, so how do we write that statement? So first, we always want to, consider the definition of p-value, and it's the chance of observing our test statistic. So even though I have negative 5.54 and positive 5.54, we always want to consider the negative, or the positive, the positive 5.54, because that's what our test statistic actually is. So we start off with writing that the probability that T is greater than or equal to 5.54. Okay, I did greater than here because my test statistic is a positive number, okay? Because when I plot, if you look over here at my graph, if I plot 5.54, the closest tail is above it. It's greater than, okay? So in short, whenever your test statistic is positive, you want to do greater than or equal to, okay? If your test statistic is negative, you would do less than or equal to. Okay, so the probability that t is greater than or equal to 5.54. Now, my statement here only represents this upper tail to the right. In order to incorporate that lower tail, okay, what we're going to do is we're going to multiply it by 2. Okay, multiplying our probability statement by 2 is what gets us to take care of both of those pink shaded regions. Okay, because again, thinking back to symmetry, what I have shaded here to the left is exactly the same as what I have shaded here to the right. So if I have two quantities that are the same, okay, but I only know one of them, how can I get the other? Multiplying it by 2. Okay, so now we always have to kind of utilize what the chart gives us. And the chart doesn't give us two-tailed probabilities. It only gives us right-tailed probabilities. So when we go to the chart, we need to just consider looking at this part right here. Okay, we're going to look up this area in the chart, and then we're going to multiply that by 2. So what area is greater than t of 5.54? That is, what is the probability that t, excuse me, what is the probability that t is greater than or equal to 5.54? Well, first thing to remember is that our degrees of freedom are 21. So we're going to go to degrees of freedom 21. And then we're going to look for that number 5.54. Okay, so 21 going across, going across, going across. We don't find 5.54. It falls off the chart, so we know that our probability has to be less than 0.001. Okay, so we come back here and we say, hey, the single tail probability is less than 0.001. Okay, but I don't just want the single tail probability, I want to double it. So what you're going to do is you're going to put brackets around this entire expression and you're going to multiply it by 2. Okay, and that 2 is going to distribute inside these parentheses to my probability statement and to the 0.001. Notice I'm not doubling 5.54, okay? I'm gonna come in here with a brown marker. Everything inside this parenthesis set should not change at all, okay? This should remain exactly the same. All right, what you're doing is you're doubling the probability and you're doubling the number that you have here at the end from your chart to have something that looks like that. Okay, so again, notice the 5.54 remains the same. So I just have this 2 in front of my probability statement because I'm doubling this probability statement, okay? And I'm also doubling the 0.001. Multiplying that by 2, you get 0.002. Okay, and so then this box would be my final answer. Okay, that's what our p-value is. Our p-value is smaller than 0.002. Okay, and so then I have in bold my final answer. Okay, you can write this either way. So all of these things that I have marked in a pink box, okay, those are all going to be equivalent. Okay, now what I really need at the very end though is the equality signs and the number that associate along with that p-value. Okay, I know this is new, it's a little different, but we've got a few more to practice and go over to kind of help solidify these ideas. Okay, before we move on to the next problem, let's consider what our decision would be. Okay, at the top of this page, it told us that alpha is 0.05. So if I come over here, 0.05 is larger than my p-value. My p-value is low. What do I do when my p-value is low? Oops. Sorry, I reject HO and accept HA. Okay. All right, so now number 8, okay, it's another two-tailed test. All of these that we're going to be going over here are two-tailed tests. And we're going to start with calculating the test statistic. Okay, so plug in all your appropriate numbers and you should get 1.12 as your test statistic. Okay, the next thing we need to write is the null distribution. Okay, so this is going to be a t distribution because we're talking about t here. Okay, and it's going to depend on degrees of freedom. Degrees of freedom is n minus 1. So t follows a student's t distribution with 9 degrees of freedom. Okay, so now we need to write our p-value statement. Okay, so let's just go ahead and start with drawing the picture. Let's draw my picture and let's plot my test statistic, 1.12, okay? And this is T9 from right here, okay? So 1.12. Now, when I'm doing a two-tailed test, I also have to consider negative 1.12. Okay. And my p-value is going to be the area above positive 1.12 and below negative 1.12. Okay. So when I write my p-value statement, I want to write it, let me get a different color, in terms of the value of my test statistic, the positive 1.12. So I'm going to look for the area above 1.12 and then double it. So 2 times the probability that t is greater than or equal to 1.12. Okay, again, this 1.12 is coming from the fact that our test statistic is positive 1.12. All right, so again, so this, what I have circled over here in my picture, that's what I'm gonna go look up in my chart. Okay, so degrees of freedom is 9, and I'm looking for 1.12. So if I'm here, degrees of freedom 9, and I'm looking for 1.12, falls right between here. So if I go up, my right-tailed, my upper-tailed probability, because that's all this chart gives us, the upper-tailed probability is between 0.1 and 0.15. So that's the first thing I write, is that, hey, this one single-tailed probability, all right, it's between 0.1 and 0.15. All right, but now what do I need to do? I need to double everything in here. Okay, so I'm going to double the 0.1 probability. I'm going to double my probability statement, as in I'm going to put 2 times in front of it, like we have over here. Okay, and then I'm going to also double that last number there at the end. Okay, so that means, so 0.1 doubled is 0.2. Okay, we add the 2 times my probability statement because now this probability statement, that's our p-value. That's what both of those pink shaded regions are up here in my chart. Okay, and I multiply the 0.15 by 2, doubling it, and I get 0.3. Okay, so the final answer is, hey, my p-value is between 0.2 and 0.3. Final answer. Okay, so then I have to come and I have to place alpha. So alpha is 0.05, which would make it down here. Okay, so 0.05 is smaller than 0.2. Our p-value is large, making our decision fail to reject HO. Okay, let's look at the next one. Okay, so again, I give you your HO, your HA, got to calculate your test statistic. Okay, and now we have a negative test statistic. So we'll get to see how we're gonna use our two-tailed hypothesis when we have a negative test statistic for T. Okay, so next thing to write is the null distribution. T follows a T distribution with 26 degrees of freedom. Okay, and then our next step we have is p-value. Okay, before we move on to p-value, let's kind of just draw a picture of what we got going on here. Okay, negative 3.464, positive 3.464. This is T26. Okay, and so we want two tails. Okay, so keep in mind now, our test statistic is negative 3.464. So when we write our p-value statement, we want to refer to the left tail now and then double it, okay? Again, this is all coming from the definition of p-value. We want to observe the value of the statistic, okay, or more extreme means go to the closest end, less than, and now we're going to also double it, okay? So our p-value statement is going to start off with 2 times the probability that T is less than or equal to negative 3.464. Okay, what I have circled in orange right here, that's this statement right here. Okay, but the whole thing, all of this, which I guess I could go do in a different color. Okay, but all of this is everything that we have shaded in pink. Okay, so now what we want to do is we want to go look up this orange probability in our chart. We want to look up being less than negative 3.464, which we are going to kind of flip across our thinking. That is going to be the same as looking at positive 3.464. Now, we want to keep in mind that what we have written in orange, this is because the definition of p-value. Now, when we go to the chart and we're going to be looking up this over here, okay, that's because we have to utilize what our chart gives us. Okay, so our test statistic was 26. All right, let me clean this up just a little. Okay. So degrees of freedom are 26, and we're looking for the number 3.464. So we're going to start at 26, we're going across, we're going across, we're going across, 3.43. So 3.43 is a little smaller than my 3.464. So 3.464 falls just off the chart. Okay, so when it falls off the chart to the right, we always say, hey, it's going to be less than 0.001. Okay, but I'm going to go ahead with my colors again. What I have written right here, this is the probability. This is the single-tailed probability, okay? Then we have to double it. We have to double it, making our final, so again, trying to stay with the colors, okay? Our final p-value, the final answer that we want, okay? That's 2 times the probability that T is less than or equal to negative 3.46 is less than 0.002, okay? And if we come in here and talk about alpha, okay, our p-value is lower and smaller than alpha. So what does that make our decision? Reject HO in favor of HA. Okay. So all these things that are in pink and starred, they mean the same thing. My notation up here where I shaded in pink, that is the visual representation of our p-value. Okay, and we get a final decision of reject HO in favor of HA. Okay, so it looks like I have one more to do with you. All right, so again, I'm gonna go through this one a little bit quicker. All right, we start with calculating our test statistic. So you should get negative 2.27. That's awesome. Another one we can practice with, looking at the negative side. Okay, the null distribution is students' t distribution with 7 degrees of freedom. Okay, so I would like to go ahead and start with drawing the picture. This is T7. Okay, and I'm down here at negative 2.27 and positive 2.27. Okay, this is all because it's a two-tailed test. And then I'm going to shade this area, represents my p-value. This area here also represents my p-value. Okay, gotta find both of those areas, and we're going to do that with multiplication. All right, so I want to write my p-value in terms of the test statistic. So it's the chance of observing this test statistic, negative 2.27, or more extreme, means go to the left and double it. Okay, so 2 times the probability that t is less than or equal to negative 2.27. Okay, so my degrees of freedom is 7, and I'm looking for 2.27 when I go to my table. Okay, so degrees of freedom is 7, and I'm looking for 2.27. 2.24, so 2.27 comes right after that. So when we go up, we see, okay, we got 0.03, between 0.03 and 0.025. Okay, so that's the single-tailed probability, is between 0.025 and 0.03. Okay, but what do I got to do in order to get what I really want? I got to double all these numbers. So I'm going to double the 0.025. I'm going to put the multiplied by 2 in front of my p. I'm going to double the 0.03. Okay, and when you do that, I see I typed my numbers just a little bit wrong. It should be 0.05 and 0.06. Okay, and then that is going to be your final answer for your p-value. Okay, so again, I transcribed that a little bit off. It should be 0.05 and 0.06. Again, the 0.06 is coming from 0.03 times 2. The 0.05 is coming from 0.025 times 2. So either of what I have in those pink boxes is going to be fine, okay? And that also represents our pink shaded region up at the top. Okay, and so now we need to state our decision, okay, based on alpha equals 0.05. Okay, well, we actually have 0.05 in our p-value statement here. So look what it says. It says 0.05 is smaller than our p-value. So that means alpha is smaller than our p-value. So what decision do we make when our p-value is bigger than alpha? That's right, we failed to reject HO. Okay, so this last one was a good example where even if the alpha is involved in one of these two ends for your p-value statement, like it was here, okay, that t-chart still gives us just enough information to be able to make a decision. Okay, well, thank you guys so much. This was your practice with two-tailed and the t-distribution. Y'all have a great day.